All right. So, as Rachel said, my name is Ollie. I don't know if I would have met any of you before, if you would have seen me on a screen near you before, but as she says, my name is Ollie. I'm the ecological modeler for NPMS, and it's essentially my job to try and make your data dance and to do interesting and exciting things. And particularly, my work has been focusing on the impact of climate change on UK plants, and that's going to be what I'm talking about in this talk today. Now, really, this is a very, very convenient time in the year, and potentially even just in history, to be talking about the impact of climate change on the UK's natural world, natural history. It has been an exceptional summer. It has been extremely dry and extremely hot. You've probably noticed that yourselves, and there have been times this summer when I have thought conditions have felt absolutely alien. Now, today, where I am, it's a bit grey, a bit cool, a bit rainy, and I'm wearing a jumper for the first time in a long time. But it really has been a staggering summer. We have seen huge areas of the UK suffering with wildfires, and not just the UK. You can see down here a graph for EU countries as well. They are way ahead at this point in the year of where they have ever previously been in all the records they've had going back several decades. And it is true, exactly the same thing here in the UK. The UK has had way more, almost 3 times as many wildfires as it did last year. One point this summer, I was driving around the M25 and we drove through wildfire smoke. That's something I'd never really thought I'd have to do in the UK. Similarly, we've had almost alien feeling temperatures. This paper here was written in 2020 or published in 2020, and it estimated the frequency of return of temperatures above 40 degrees C, which they chose as a very high threshold for real extreme temperatures. They reckoned that under natural climate conditions in the UK, somewhere in the country might surpass 40 degrees C every maybe 250 years, but certainly hundreds or thousands of years you'd have to wait until you saw somewhere in the UK hit 40 degrees. Our climate has changed, so we don't have the full natural climate anymore. And at the moment, you'd still expect to have to wait a few centuries. What happened this July was a once in a century, 2-3 centuries kind of event. However, our climate continues to change, and as we continue to emit greenhouse gases and to consume out of proportion to what Earth can support, it's likely that these temperatures, the kinds that we had this summer, are going to get more and more common. Under a medium emission scenario, it might happen every decade and a half. Under a high emission scenario, which hopefully we won't reach, they could happen every handful of years. Now, at the point this paper was written, the UK had never seen in the recorded history a temperature of 40 degrees, but of course it happened this July, and it is significantly the result of climate change. Now, we've got similar things happening with droughts. You may well have seen pictures like this of reservoirs and lakes. It doesn't just affect the UK, it's affecting much of Europe and further afield, significantly in China as well. You've got huge swathes of Europe under some kind of drought warning, and something that probably hasn't happened for the best part of half a millennium. And all of this is not just this year being exceptional. It's part of a broad long-term trend. This is part of the Met Office's State of the UK Climate Report, and it shows that the last decade has been warmer and sunnier, also rainier and less frosty than the decade before that, from the last 2 decades, from basically 1991 to 2020, and significantly warmer and wetter and sunnier and less frosty than it was in the late 20th century. Now, my grandma Wilson is in her mid-90s now. She has never lived through a summer like the one we had this year, and the current years, these are the warmest and the driest that she has experienced. But what's worrying is that this is likely only to get worse. So my son, who's 3, might well think that this is fairly routine by the time he gets to be in his 90s. We can look back a long way at very long-term temperature series, something that the UK almost unique around the world in having, going back to the mid-1600s. We can see that the changes in the temperatures that we've had in recent years have got no parallel anywhere previously. So this, understandably, is a huge upheaval, a big disruption in our world, and it affects all sorts of things. It's affecting power plants, it's affecting even things like runways which are melting, but it is, of course, having a huge impact and will continue to have a major impact on UK's habitats and wildlife. And that's where ecological monitoring programs come in. These are fantastically useful resources for understanding how ecological changes, driven by all sorts of factors, but including climate, it's for understanding how those are unfolding. We have got things from the Bat Conservation Trust, there's a seabird monitoring program, a breeding birds survey, a butterfly monitoring scheme, and all of these schemes, mostly focusing on animals, have been going for decades now. Until the last few years, the only scheme that was looking at habitats at large and the plants within them was the Countryside Survey. Now that had its first survey in the late 1970s, but it's been very sporadic. It happened, a CS Countryside Survey happened in 1978, then again in 1984, 1990, 2000, 2007. From 2019, they started becoming slightly more frequent, but the NPMS has an extremely important role in sitting in the middle of these different ecological monitoring schemes. It is the place where we can frequently monitor what's happening to plants and therefore the habitats they form around the UK, and to see what changes are happening. It is a vitally important scheme. It was the first one that was aiming to do frequent observations of plant abundance, and that has unlocked a lot of useful data to understand what's happening around our country. So I'm going to skim through well, not skim, I'm going to wander through some established uses of NPMS data, some things that we have just newly done, some things that are fairly recently completed, and then to finish off with a look ahead at things that are in the pipeline, stuff that we're going to be looking at in the future, using data that NPMS surveyors, maybe like you guys, have been doing. So the first one, the most established use of NPMS data is as part of the UK Biodiversity Indicators. Now, these are an extremely useful set or suite of indicators of statistics that show us how the UK's biodiversity has been changing through time. So this, for example, is something called the Spring Index. It's all to do with the first observation of some species of butterflies or of swallows, or the first flowering of things like hawthorns or horse chestnuts. And it gives us an idea of how early in the year these things have been happening. And you can see that as time has gone on, with the exception of this large unmonitored period here, these things have been happening earlier and earlier in the year, a marker of climate change. Now, we looked earlier at those different ecological monitoring programs, and most of those are the basis of statistics used in the biodiversity indicators. So we have farmland birds, water wetland birds, things like bats and butterflies, the wider countryside, specialist butterflies, and all of these different statistics allow us to see how their status has been changing through time over, in most cases, many decades. Again, because the UK, until the NPMS started up, didn't have a high frequency abundance data for plants. This hasn't really been possible for plants until quite recently. So we had for a while these data from the Countryside Survey, where you had 3 time points and looking to see to what extent things had changed over this decade and a half of data. The NPMS has allowed us to see in much more granular detail through time how positive and negative indicator species of different habitats have been changing. So we get to see some potential declines in arable field margins. We see that bog and wet heath is doing less well, was doing less well in 2018, 2019 than it was at the beginning in 2015. And being able to continue monitoring these things for the long periods of time necessary to see these changes will help to give us an impression of how well these organisms, these habitats are changing, how well they're adapted to these conditions. It will give us an indication of whether there is long-term damage being done or whether these habitats are recovering. And it will help us to see the potential impacts of targeted help and changes and habitat management strategies for them. Now, this is established. These have been in the biodiversity indicators for a couple of years now. I think the indicators package is getting reviewed and revised at the moment, so it may not have been updated recently. But there are other things we're planning to do with the NPMS data as well. So one of the ones I'm going to spend a bit of time talking to you about is something that we've just finished doing, a bit of research that we're just concluding, which is to use the NPMS as part of an assessment of the exposure of UK habitats to past and future climate change. We're interested to know what have habitats experienced in terms of climate change through the 20th century, and what might they experience looking ahead to the end of the 21st. And then also interested to know how well do the UK's plant monitoring schemes capture those gradients? Are monitoring sites clustered in areas that are accessible and very exposed to climate change, or do they manage to capture the broad spectrum of areas, including ones which are less exposed, more exposed? Is there a bias there? That's really important to know, because if we want to understand how the UK's plant communities are changing or have been changing to climate change, we need to know how those data reflect the fuller reality across the country. Now, this is a bit of research we haven't yet managed to start, but will be coming in the pipeline very soon. We're looking to see, are we seeing changes within the UK's plant communities? Are we seeing transitions to ones that to plant species that prefer warmer conditions or drier or more seasonal conditions? And do we see the same trends over the sort of 7 years of NPMS compared to what we see over the sort of 30, 40 years of countryside survey data? This is something that I'm going to touch on again a little bit more later on, but I want to zoom in now on this first component, this assessment of the UK's exposure to climate change and how that relates to habitats and ecological monitoring schemes. So here is some more data from the Met Office, which is a fantastic trove of data for things like this. On the top rows of each of these two graphs, you've got January conditions. On the bottom, you've got those in July. On the left-hand pane here, we have average temperatures for those months. And on the right-hand side, we've got the rainfall amount for those months. And you can see here these different timeframes, the beginning of the 20th century, the sort of middle-late 20th century, and the last decade. What these show is that the UK has been getting warmer, both in winter and in summer, and it's getting wetter winters, this sort of slightly more intense white color coming up through here, and also drier summers, this darker, blacker colors emerging here in the July one. So the UK, from the beginning of the 20th century to the last decade, has got warmer with wetter winters and drier summers. And if we look ahead to predictions for the rest of this century, we can see that these are trends that are expected to continue. It's worth noting that these predictions for the future are under pessimistic climate change scenarios, but especially for the next couple of decades, the climate change scenario doesn't make very much difference. We would expect to see the UK continue to get less, well, if you like, milder winters and hotter summers, with those winters getting increasingly wet and the summers getting increasingly dry. We can synthesize that to look at different climate types. This uses a system called the Kerf and Geiger climate classification system. And again, we have here these different maps that show you different points in time. And you can see that these upland climate types that were quite common in the beginning of the 20th century have got less common up until now. This sort of dark green color has disappeared to a large extent or has reduced significantly, as has this gray, very cold highland climate type. In particular, you can see in England and Wales, these highland climate types have really reduced through time. And we can also see that as we look towards the future, we not only get a continued loss of these colder climate types, we start to get an introduction of other warmer, drier climate types, especially in the south. So the prediction here is for the next couple of decades to have the beginnings of warm and dry summers, where these dry summer climate types haven't been observed before in the UK. And possibly, should climate change continue at its current pace, we may see whole new hot and dry summers, I think meaning over above 30 degrees C, across a large part of England. These are climate types that haven't been in the UK since at least the beginning of the 20th century, and probably for a very, very long time before that. To put them in context, this is where those climate types are currently found around Europe. So we're looking at the loss of these much colder kind of alpine or tundra type landscapes, climate types from upland areas, and a shift towards climate types that are found currently in Portugal, Spain, and along the Mediterranean coast. This has been a significant change. It could be even more significant. Now, to understand how this impacts on, or this translates to impacts on habitats and to potentially plant communities, it's important to convert this into a metric of climate change exposure. We need to understand essentially how much has a particular place changed its climate. And so I won't bore you with the statistics that we did to do that, but I want to show you a few maps that show how the UK's climate change exposure has been shifting through time. So in general, as you move up this scale on the left, the sort of increasingly hot colors show increased climate change exposure. Now, in the 20th century, obviously there was some climate change. It was comparatively minor. You can see roughly where the sort of warmer areas of greater climate change occurred. That there was a step up again from within the 20th century to sort of the 60s, 70s, and 80s through to the last decades. Much greater climate change happened in that time period. But as we start to look forward towards the future, we see greater climate change again, and under a pessimistic emission scenario, even more looking towards the end of this century. Now, it is obvious that these the impacts of climate change will not be felt similarly everywhere. And one of the things you might be noticing when you look at this map is the areas which have high climate change exposure are not necessarily the ones you would think of as being most vulnerable to climate change. If you think about habitats or locations which you can imagine are going to be suffering from climate change, it's generally the colder, wetter ones at higher elevations. Now, I did do some analysis on this, and it turns out that actually higher elevation areas do have greater exposure to climate change compared to ones nearby. But on a broad picture scale, it's principally southern and central England has the biggest regional exposure to climate change. It's where the climate is going to change the most, or will have changed the most, of all parts of the UK. And that raises a question: what impact will this have on different habitats in the UK? What is it going to do for, say, calcareous grassland, or for salt marshes, or for bogs or heather grasslands? So the next stage of this analysis has been to take these maps of climate change exposure, of examining what changes these locations have seen and might see in the future, and to overlay it onto this map of land use. And so what we have here is a graph that kind of shows where or how those different habitats have had different levels of climate change exposure. Now, the first thing I need to draw your attention to is the scale on the bottom. This is called a logarithmic scale. You may well have seen it in COVID data. It's a helpful way of separating out things that are changing exponentially. So the changes here on the left-hand side of the axis are really very small compared to the changes here. This gap here is 10 times larger than the gap here, for example. But this is a useful way of separating out changes so we can see within groups how things are changing. So here, if we look at the triangles, we see that within the 20th century, when there really wasn't all that much climate change, though that it wasn't absent, we see things like neutral grasslands and coastal rock, so things like cliffs, seem to have quite high climate change exposure. As we move from the 60s, 70s, and 80s through to the last decade, we start to see a different pattern emerging. We start to see places like arable and horticultural land, also urban, suburban, calcareous grasslands, and things like fen, marsh, and swamp all ended up having quite significant changes in their climates from late in the 20th century through to the last decade. We start to see similar patterns too as we look towards the future, the next couple of decades, and later in this century. And this list is ordered by the total climate change exposure by these different land cover classes. Now, I don't know if you monitor NPMS squares yourself or what habitats those are in, but it's worth considering. If you have any of these habitats in there, your squares will have been undergoing climate change. You will be starting to see at some point the impacts of that as you continue to monitor it. Some of them have got more exposure, they've changed their climates more. It doesn't necessarily translate to having greater impacts of climate change. That will depend on things like how much leeway habitats and species have, and populations and communities. How much leeway do they have to adapt? How well can they change and respond to these changes in conditions? But it's worth considering that wherever you are, whether you're looking at communities with probably less latitude for adapting, things like highland bog or heather grassland, they may not have suffered huge amounts of climate change, but they may be much more sensitive. By contrast, if you think your plots are boring because they're near fields and there's not a huge amount of interesting, exciting natural habitat near you, it is still vitally important that we get that data, because those are areas that are going to have gone through a large amount of climate change and therefore might give unexpectedly large changes back when we analyze that data. So I said that there were two components to this bit of research. The first was figuring out how the UK's different land cover types have been exposed to climate change, and this kind of gives us some of that answer. But if we want to go to the next and most interesting step, the one that's in the pipeline, to see how the UK's habitats and plant communities have been changing, we need to know how the data we have on those communities relates to the wider communities, whether we have data on or not. And so we need to find out how good a sample are ecological monitoring schemes like the NPMS and the Countryside Survey, and how well can we extrapolate from the data we have to the wider countryside. So in a moment, I'm going to show you a grid of graphs that's made up of individual panels that look like this. This is a panel that shows you how well different monitoring schemes reflect the general picture in a habitat. So at the bottom of each of these panels, you have got the overall picture of climate change exposure for that land cover type. So in this case, broadleaf woodland. So this tells us where the climate change exposure was, from low exposure through to high exposure. And this dot here tells us the average climate change exposure for a random sample of this habitat. The lines that go above this are different ecological monitoring schemes. We've got the NPMS, pardon me, in purple, the Countryside Survey in this kind of golden brown color. We've also got two smaller ecological monitoring schemes, the Long-Term Monitoring Network here in red, and the Environmental Change Network here in green. Now, those are two sites that don't strive, those are two schemes, they don't strive to do what the NPMS and Countryside Survey do. Now, NPMS and Countryside Survey aim to survey across the UK. They try to get a representative, in different ways, representative sample of UK habitats and land cover types. ECN and LTMN, these other two networks, they choose specific sites and they monitor them extremely intensely, and have done for decades now, to understand what's happening there. And what you'll be able to see as you look through here is how many plots we have available from each of these different survey schemes, how well they overlap with the random sample. So a high overlap means that this is a very good representation in this scheme of the wider habitat. And you'll be able to see where the survey locations overlap with a general climate change exposure. So in this case, for broadleaf woodland, the ECN sites are predominantly at the most climate change exposed parts of broadleaf woodland. That would mean if we were to take only ECN data and to try and understand the impacts of climate change, we might be overestimating what we see, because we're only really looking at the most exposed, probably the most changeable or the most affected parts of that habitat. So as we look at the grids in the next couple of slides, be thinking to yourself, which of these schemes is providing good coverage, high percentages of the general habitat? Which of them provides lots of data on those habitats? Because the more data we have, the easier it is to understand what's happening more generally. Are there any that are wildly overshooting with their average dots to the right, or undershooting the dots to the left, the general picture for that habitat? And start to thinking, well, which schemes are valuable? How well does NPMS in particular do for this? But before I click on and start showing you these other graphs, I've done this when I've done this presentation before. Does anyone have any questions about interpreting this? Because I appreciate that this is quite a lot of information to pack within one panel, and there will be quite a few of those panels in the next couple of slides. I'm going to pause for about 30 seconds. If you've got a question about it, please just type that in the Q&A box, and Rachel can feed it back to me and I'll try and answer it. And if there's anything that you're not sure about how you understand that, please just ask that in the next couple of seconds. I realize now that this means you're just going to be staring at my silent face for a bit.
That's a perfect opportunity as well for me to say, Ollie, folk, you probably will have noticed as well when we first started the meeting that this is recording as well. You'll have seen when you first joined onto the Zoom, but I thought it was worth putting a reminder in now, just because obviously there's a lot of information. It's all really interesting, but it will be all made available again on the YouTube channel. So hopefully you can sit back and relax and enjoy as Ollie's going through. Not expecting, to remember absolutely everything. It will be up on the YouTube channel within a week or so. So that was a good opportunity for me to say that if anybody is typing anything.
Okay, I think in the absence, am I right in thinking, Rachel, there's no questions that come up at this point?
Nope, I can't see any that's come up so far.
Okay, well, in the absence of any questions, just for now, if you still have a question about this particular interpretation, please ping it in there and we can answer it as we move on. But in the absence of those, I'll move the slide on. So just as a reminder, we're looking to see how well these shapes match the filled in shapes at the bottom, how high the percentages are, especially for the purple NPMS, and how many different plots we've got for these different monitoring schemes. So if we look at historical climate change, we see this kind of result. Now, you might like to find the habitats that you monitor for NPMS. You might just be interested to kind of skim through. But I did want to pick out a few highlights and headlines from this graph. And they also apply to one I'll show you in a minute of future climate change as well. The first is that there's a lot of variability. The coverage is variable between the different schemes. So as you move from the different colored lines, you can see that there's quite a big differences often between them. It's variable across habitats and land cover types. So as you move from one panel to the next, you'll see the numbers change quite significantly. It's also variable between time periods, which you'll see in a moment when I click the slide onto the future time period. But there are some general things that you can draw out. One of them is that probably the best overall scheme is the Countryside Survey. That's to be expected. This uses professional surveyors. They cover huge amounts of the UK. They do it in excruciating detail. And it's designed to cover almost immaculately and sample the UK's habitats. It comes top in half of the sort of habitat and time combinations that it appears in. It's got the highest overall overlap, and its average values for climate change exposure come closest to the sort of habitat averages. But the next best scheme, or the other best scheme, is NPMS. It has wider coverage. It covers a wider range of habitat types than the Countryside Survey seems to do. And it is quite a close second for the overall overlap with the habitat average values and for the averages that it's got for that coverage. So you can see, for example, for acid grassland, the Countryside Survey here in gold has got the highest overlap. It's got a very neat match really to the general picture for the habitat, a very close average, but NPMS still does pretty well. It's got 70%, which is obviously not quite as good as 84%, but nonetheless, it's not too shabby at all. Ditto for arable and horticulture, where NPMS does extremely well. And you see this pattern appearing in lots of these different places for broadleaf woodlands, even for things like coniferous woodlands, where NPMS seems to do slightly better than the Countryside Survey. Now, it's also the case that you can see these other two schemes I mentioned, the ECN, the Ecological Environmental Change Network, and the LTMN, the Long-Term Monitoring Network. They generally have less impressive general coverage of the broad habitat trends than do NPMS and the Countryside Survey. However, they also provide some extremely useful coverage for habitats which otherwise don't get very good coverage in the sort of more widely dispersed schemes. So thinking about things like inland rock, where NPMS does the best, but is closely followed by the ECN. You can do similar comparisons for other ones, things like salt marsh. There's important data coming from the LTMN. So this shows us that there is real value in having these ecological monitoring schemes, but in particular, it shows us the NPMS is doing a really important job. And whether we're looking at past climate change, as here, or future climate change, as in this slide I've just changed it to, NPMS is going to be incredibly important for understanding the impacts of climate change on UK habitats and on UK plant communities. Add into this the fact that NPMS is very frequently done. It's done much more often than is the Countryside Survey, and it covers a vastly greater number of sites. You compare these numbers on the left-hand side of each panel than any of the other schemes that we've looked at here. NPMS provides a valuable, an extremely valuable set of data to help understand changes, particularly for climate change in the UK's biodiversity. I'll leave this here just for a second so you can have a quick peruse of the numbers if that's of interest to you. So NPMS data that people like you are collecting and have been faithfully collecting since 2015 is going to be enormously important for helping to understand what this climate change exposure has meant for different species and communities and habitats around the UK. Now, that is something that is going to be happening in the next phase of this project. It's next on my to-do list. And we're hoping to produce something that looks a little bit like this study that was done on a similar project with Vigiflor in France. What they found was that if you looked at the thermal preference, essentially how warm do the plant species of, or how warm do French plant species like to be, you saw this upward line, this upward trend of increasing preference for warmer conditions from 2009 through to 2017. That trend was even more pronounced if you looked at annual plant communities, ones that with species that kind of renew every year. And we also saw that areas that had seen greater temperature change, so if you like greater climate change exposure, those areas had seen greater changes in the thermal preference of their plant communities. Now, the plan is to do something quite similar to this for UK species using NPMS data and probably countryside survey data to give that more sporadic but longer term vision of how the changes have been unfolding. We think initially we're going to focus on broadleaf woodland, which is very widespread and has got a lot of data points. We're going to look at calcareous grassland, which ends up being one of the most climate change exposed habitats we examined, and possibly something like neutral grassland, which is also well surveyed by things like NPMS, and which also has had, especially historically, quite high climate change exposure. So one of these future questions that's going to be really important for us is to find out how have the UK's plants changed. At the moment, we don't have answers for that, but having done that previous study to understand how the connections or how you can make connections between data like NPMS and broad habitat coverage of climate change, and how you can go from exposure to, as you remember, those indicator lines, linking all these things up gives us a great opportunity to understand what climate change in particular is doing to UK habitats. But it's not just limited to climate change. It's been the focus of this talk and it's been the focus of our research at the moment. But it's important too to note that there are other things that we're going to be doing with NPMS data down the line. And in fact, not just us, the data is open, so anybody's able to use it. One of the most important things we could look at is the impact of nitrogen deposition on plant communities. We could use NPMS data as a really valuable way of ground truthing, of checking predictions from satellites on what is happening to the land, of how land cover is changing, and of what different land uses are in different locations. We could also use the data to help us understand the impacts of different agri-environment schemes, for example, or changes to land use. NPMS data is incredibly valuable, and in a way, the limitations on what it can be used for is principally due to the imagination of researchers. I've given you a bit of an overview of how we've used it so far and how it's already in use. And this is just a few ideas about what could be happening to it in the future. So as I wrap up, I appreciate we can have a little bit of time for questions at the end if that's of interest. But at the moment, data from NPMS volunteer surveyors is being used to provide a nationally important indicator for biodiversity, looking at plants of the wider countryside. It's feeding into policy and it's used to monitor the impacts of changes to land use and policy and through broad drivers like climate change. NPMS data we found from our research is also one of the most valuable sources we have to help understand the impacts of climate change on UK habitats. So level with the countryside survey, there isn't really any other comparator that can give us that same kind of detailed information on the abundance of plant species and their changes through time on fixed locations over the long term. It really is incredibly valuable. And when we look to the future to understand how we're going to use that data to see what is happening actually to those plant communities, NPMS again is going to be right at the forefront of that. And not just for climate change, it's also going to be hugely valuable for things like nitrogen deposition, land use, and much, much more. To sum up, NPMS and the data it's producing is immensely valuable. It's only thanks to the surveyors who've taken part, we're able to do all of these things. And it is going to be absolutely critical for understanding how the UK's climates and the habitats that are impacted by it are going to change into the future. So I'm going to stop sharing my screen now. And if you have any questions, please pop them in the Q&A box. whether about this, as Rachel said earlier, NPMS more broadly, we'd be happy to listen to and answer them.
Thank you so much, Ollie. I really enjoyed your sort of the final inspirational ending there. That was like a call to action. I loved it. Thank you so much. That was so useful, and as I say, quite inspirational for, you know, encouraging us to get out there and collect the data and submit it. Indeed, there's no point collecting it if we're not then entering the data. So as Ollie said, is an opportunity now. Should you like to ask any questions to us, both on Ollie's presentation, but also if you have anything more general that you would like to ask. I can see one has just popped up here, Ollie. I will read it out loud to you. How do you envisage using other sources of information, for example, from the BSBI database, which is huge, and has records going back much longer times? So how do you envisage using these other data sources as well?
So they're vital as well, to be honest. The more data we have, the better we're able to answer these hugely important questions. And you know, obviously, it's important to recognise, as the questioner did in the writing, that the data have flaws. All data does. There's something we saw in that presentation where some locations sampled very intensively are somewhat biased. Now, that's very valuable for some things. It makes it difficult to draw conclusions in other senses. Things like the BSBI database provide extremely valuable data on where plants are. So at the moment, the BSBI is, I think, just putting the finishing touches to its atlas.
Yeah, as we speak, I believe.
Rachel? Yep.
Yeah.
People have been beavering away on that over the last several weeks, well, for not much longer than that. And it provides hugely useful data on where plants are, because the BSBI database principally looks at location data. So where are things, distributions. NPMS, one of its huge benefits is that it looks at abundance. You know, if you go to an NPMS plot, you're looking at the dominant scale, the coverage of different plants. And that's very valuable, because it may well be that plants are becoming rarer but not disappearing from different locations, and that can give us, if you like, an early warning, which would be lost in things like the BSBI database. Inevitably, in all these things, it's not a question of saying this is the ideal data set, we don't need any others, but of using these things in tandem. So things like the atlas give us a great vision of where things are moving and where they might be retreating or advancing. NPMS gives us a really great picture of what's happening within that. And because the NPMS has got this sort of standardization and its sampling framework built into the study, you know, you can't just sample wherever you want to go. That makes it much easier to extrapolate out from the NPMS locations to the wider countryside. For things like the SBI database, it's slightly more complicated, because there'll be biases and where people go and how often they go and things like that. Yeah, so I think hopefully that's a fairly useful way of looking at it. Essentially, all the data is useful. Keep going. Well,
that's it. As you say, these schemes, it's not a case of one being the scheme to go towards. They're all really contributing different information. And as actually the original question did include, you know, that sometimes these records can be patchy at times depending on the different monitoring schemes. So hopefully by, you know, working together, we can build that bigger picture.
Yep.
So I have another one, which is more of a personal question to you here, Ollie. Somebody here, I think possibly equally as impressed as I am here with this presentation. Your knowledge of this data is tremendous. Is your background in statistics?
No, my background is not in statistics. I didn't really love statistics when I was at university, but I've got an undergraduate degree in biology, a master's in a slightly niche subject called ethnobotany, which is the study of plants and people. I've just finished a PhD in ecology, in environmental science, which spanned paleoecology, archaeology, and looking to the future. I just have a bit of a habit of burrowing into stuff when I'm interested in it, and so and ended up over the last year and a bit really getting to know the data sets and things like the BSBI, but NPMS and these other data, really quite getting quite familiar with them. So that's how I'm able to give off this impression of understanding the data very well.
That's also the way that you present it, Ollie. You have a very good way of getting across the information. And I think I go back as well to something Ollie's already mentioned, is as well that the great thing with NPMS is there was so much thought gone into the survey design about how the analysis would be carried out later, which, you know, actually, believe it or not, you'd think that should be common practice, but quite often it can be the case that people get a heck of a lot of data at the end and then think, right, how are we then going to analyze that, or what, you know, what specific questions are we going to ask? But NPMS was absolutely sort of meticulously designed right from the forefront with that in mind. What particular questions are going to be asked? What exactly do we want to know about this? And very much the analysis that was going to take place later was really considered when it came to the survey design.
Absolutely, and that's one of the things that is possibly not so visible for NPMS surveyors. You know, it's something, as you say, that's been shot through all of the NPMS planning and designing, and it is one of the things that makes NPMS so incredibly valuable. It's one of the reasons, it's not an accident the NPMS comes out so well in this analysis. It is designed to do exactly this kind of thing, to do a really good survey of the UK's semi-natural habitats.
Thank you. So I'm just going to have a quick look at our chat. I can't see that we have any other particular questions. Now is the time if you do have any questions, again, either on Ollie's presentation or anything more general. Give it a few seconds, as Ollie did previously. Thank you very much, Ollie. You clearly enjoy making the maps and the models as well. That, do you know what, there's a lot to be said for making a very clear image to accompany what you're saying, because it can get so confusing otherwise. So thank you, I really appreciate that as well. Right, I can't see that we are seeing anything else. So what I would say is, again, if you'd be interested to watch again, or even if you have any questions, that if you're anything at all like me, you'll think at the moment, I can't think of anything, then you'll go away, you'll make a cup of tea and think, oh, I wish I'd asked that. I will, of course, be on the support email, the support of the NPMS support email address if you have any further questions. We do have a question here, Ollie, that has said, what's the best way to contact you directly? Would that be through NPMS, Ollie?
Yeah, probably the best way is to email the NPMS support email address, and then it will find its way to me.
Yeah, well, that's it. It's a bit of a team effort here, so they tend to be fielded to the person appropriate for the question. So I hope that helps. As I say, if there's any questions on this particular presentation, or even more generally, if you want to pick Ollie's brain, sorry, Ollie, I'm volunteering.
No, please do.
Your time
please do.
here.
Yeah, my brain is open to
any
all.
particular. That's great. Yes, I can see you just interested to hear more about your research. Well, that's brilliant. That's exactly the response we want. That means you've enjoyed it and you want to find out more.
I should also have pointed out that with the research that I said we've completed is written up, and we're hoping to submit it to a peer-reviewed journal in the next month, maybe month or two. Yes, so it will at some point be making its way out into the world.
Yes, as soon as possible.
Easily and widely read. Yes.
Yeah, as soon as that is the case, it'll be placed in various NPMS news outlets, whether it's social media or newsletters or whatnot. So we'll be making everybody aware of that when that is published, as you say. So yes, if you've got any questions, don't hesitate to get in touch with the support at NPMS email. And as I say, this will be going up on our YouTube channel, along with a whole raft of other videos that we have available on there. It should be going up now in around a week's time. So you'll be able to watch it again, should you choose to do so. Other than that, thank you ever so much, Ollie.
You're very welcome.
Thank you very much, everybody, and some lovely questions. So thank you ever so much.